It's time for turbo mode. Woohoo! Get up there. Come on. In today's video, we're going to go ahead and take a look at the wheel joint 2D. So let's go ahead. We'll open this up. It's best demonstrated on a car. So I'm just going to go ahead and jump straight into that. I'm going to grab my car, the red body, put it right about here, I guess. And in case anyone's wondering, this sprite sheet actually came from opengameart.org. And I'm just going to go ahead, grab a red wheel. I'm going to put it right here. I'm going to duplicate it, move it right about here, and let's get this set up. So to get this to work, I'm going to need a few things on the car. The first thing I want is a polygon collider 2D, just to kind of map out the mesh. We could go with box colliders and compound colliders. Let's just keep it super simple and quick. We'll throw a poly on it. And we're also going to need a rigid body 2D. Great, we got both of those on. I'm just going to leave the default values. If you are actually watching this to make a car, you are going to have to play around with some of these values to get it set up exactly the way you want it. But for the actual body, this is all we need for the demonstration. Now for the wheels, I'm going to go ahead, select them both. I'm going to add a circle collider, 2D to them. And it looks pretty tight. I guess I could bring it in a bit more, maybe even move it up a pixel. I'm not that worried about getting it perfect because, well, it's for demonstration. So I'm just going to go ahead and leave it with the defaults. We also need rigid bodies and wheel joint 2Ds, but if we just go ahead and add the wheel joint 2D, it'll automatically add the rigid bodies for me. And I'm going to go ahead and just leave them at the default value. And by default, if we take a look here, the connected rigid body, it's just going out to 0, 0 because that's what we have it set for. I'm going to go ahead and assign the car body as the connected rigid body. Now I have both of them selected, so it assigns it to both of them simultaneously. And it's going to go ahead and assign them to wherever its pivot point is. And I don't want it there. Let's take a look at this. This is the anchors. I'm going to go ahead, tick off the auto configure connected. This allows me to adjust each one independently on my own. And let's just start with the front wheel. I'm actually going to quickly just rename this F wheel. And let's actually go ahead while we're here. Let's call this B wheel. In case you haven't figured it out, it's front wheel, back wheel. Okay. So if we come down to the anchor at 0, 0. Now this is the local space for what the wheel is going to spin around. Generally, you want it in the center. Now the connected anchor, this is where the wheel is going to try to sit on the car. So think of it as the axle. I'm going to grab that, move it pretty much straight up. I'm actually going to leave the axes on. Now I'm probably going to have to adjust these as I go along, but right about there. And I'm actually going to copy that Y position. And when I select the back one, I want to go ahead, get it down here. And I'm actually going to copy the Y so it's at the exact same Y position. And let's go ahead and hit play and see what happens. I'll zoom out a bit. So all we've done is adjusted where we want the tires to rotate around and where we want them to sit on the car. Now it looks like I've got to move this one forward a bit to be perfectly centered. Again, I'm not too worried about it. This is just for demonstration purposes only. Now the next thing I want to look at is the enable collision. If we go ahead and tick this, the wheels can't go through the collider on our rigid body car up here. They'll sit under it, and we don't want that. Go ahead, let it go. Whoops, we've got to actually tick it. And it's also going to interfere with the car trying to move. I've gone ahead and I've turned the front wheel on, and I have not turned the back wheel. If we did do both, let's grab both. Take them both on. There we go. And the wheel's trying to get there to the spot where we defined it as the axle, but it can't because it can't get through that rigid body. So with the car, we're going to go ahead and leave it off. I'm sure there's other instances where you would want that on, but for creating a car, we don't. At least not this car. Maybe if you have some giant monster truck or something. But anyway, we've got that turned off. We've looked at the anchors. Next, let's come down to motor. Now, motor speed is how fast you want your car to move. I like to think of it as the top speed. And the maximum motor force is how much force is applied each fixed update to the rotation to get you to that maximum speed. So I think of it as acceleration. Now there are other factors that come into play. For instance, if we go ahead and take a look at our material for our colliders, we could go ahead and make a very high friction physical material so that we can, get more traction and go. But let's just go ahead and we'll play with these properties. First, we'll start off with a 100 speed, not that fast, it's max speed. So it's going to rotate 100 degrees per frame, but I forgot to actually tick the use motor. If we do not tick the use motor, these properties don't matter. So we'll tick it. Now we should get a little bit of momentum forward. And we have 1,000 force pushing it. So while it doesn't go that fast, it has a lot of torque to help push it over things. Now in this particular scenario, our collider's colliding, but there we go. We just keep going, we keep trucking. And I think we're going to get stuck here. Yeah. All right, so we'll go ahead, we'll turn that off. And let's take a look at the maximum speed, or the maximum motor force. I'll go ahead, we'll turn this up to 1. And while 100 is the maximum speed, we only have a force of 1 pushing it. And that's not enough to be able to get it up over this hill. So eventually it could reach up to the maximum speed of 100, but it's going to take a while to get there. So again, if you're not worried about all the physics things, you just want to know what it does. Max speed is the motor speed, and acceleration is basically the motor force. I'm going to put this up to 100, and you can get really crazy with this, but you're going to have to play with the other settings before you can really start ratcheting this up or down. As we can see here, the tires are trying to rotate way too fast. Anyway, let's crank that back down. Let's go with 200. Can I handle 200 with the current settings? I can. And it looks like it, well, not quite enough to get me over that hump. I might actually have to lower it for this car. So we've covered the motor. Let's take a look at the suspension next. If we zoom in, I still have both wheels selected. I am actually going to move this up a bit more. A little bit less bounce. It looks like that one's off center a bit, but that's fine. I'm down a little bit. I'm going to zoom in just on this one tire. And we'll turn that off. And I actually do need it down just a bit more, actually, to really demonstrate this next part. And I want to keep the tires at the same height. So I guess we're better off leaving them down there. Okay, so I've got this one tire selected. Let's take a look at the angle. This is the angle the shock should move to for your suspension. And right now it's set at 90 degrees. 0 is this way, 90 is up. So if you don't want your shocks on your car to bounce upwards, if you want them to bounce in certain directions, you can go ahead and change that. So let's get it to bounce this way. We'll type in 45. And now we can see the line where the suspension goes. So instead of bouncing straight up and down, you're going to bounce kind of forward a bit. Depending on the type of car you're making, you might actually want to change that property. Now the next one is the frequency. And that is how stiff your shocks are going to be. The higher the number, the stiffer it's going to be. So let's go ahead and crank this up to, say, a 10. Let's get crazy. Let's actually go to 100. And there's not going to be any bounce at all, probably at 100. And I only did the one tire. But we take a look here how the back end bounces a lot more than the front end. Let's go ahead and we'll do both of them the same. There we go. So no bounce whatsoever. Now one of the benefits of less bouncy, you can put more force on it. Let's bring this back down just to demonstrate. We'll go to a 1. Now we've got lots of bounce and lots of movement. Some of these physics are just hilarious. Inchwormers way by that car, or by that bump. You can do it. Will he make it? Will he make it over the edge? Oh, he's had a bit of problems here. I just don't think he has enough friction. All right, we'll go ahead. We'll stop that. So the next thing we'll look at is the dampening ratio. I'm going to go ahead and put my frequency at 2. The dampening ratio goes between 0 and 1. And the higher the number, the less movement you get in the spring. So while the frequency controls how bouncy the spring is, The dampening ratio controls how fast you move up and down on that spring. So to demonstrate, we'll go to a full 1. Very little movement. And let's take a look at 0 now. Go to the other extreme. As you start playing around with these settings, it can become quite apparent with some of them. So notice how the car has much more bounce to it, at least the wheels do. Let's go ahead, we'll turn that off. And I'm gonna go back up to, I think 0.7 is the default. Right now I like that, maybe a little bit harder, not quite harder though. And I'll take a 4 for a frequency. We've coupled the enabled collision, the connected rigid body, the configure connected, the anchor, suspension, the motor. Let's go ahead, we'll take a look at brake force. So brake force is how much force can be applied in any one direction before this brakes. So if we put something super low, and what I mean by this brakes, I mean by the joint. We'll go ahead, we'll start it. And we're adjusting both. They both broke right away. Let's see if we can't get a little bit higher. Maybe an 80, so when we get over a bump, maybe one of the bumps will break it. And I think it's because I have my car up too high. Well, there we go. So the front tire broke, but the back one didn't. And of course, if we select it, we see that the hinge joint is gone. Well, on the back one, we still have it. Sorry, not the hinge joint, the wheel joint. I'm going to go ahead, make sure they're both selected. I want to go back to infinity, which we get by typing INF. And the brake torque, let's try 100. And this goes, if it starts spinning too fast, it'll brake. And my car is probably not moving fast enough to, quite honestly, break a wheel. So I'm going to go ahead and set the brake torque to 99, and it is going to brake it instantly. But remember, if it starts rotating too fast, if it has too much force rotating the tire, that's what breaks it. Yeah, and we have it set to 100, so it breaks it. So I'm going to set this back to infinity, and I believe that's all the properties so far. Let's go ahead and take a look at a car that I've already set up and played around with the settings a little bit. I'll open this up, and let's take a look at the wheels. I've got them both set to the same. So I've actually gone ahead and added a fairly high friction physical material to it. But I've gone ahead and really cranked up the dampening ratio so that I move pretty quick to the position I want. My springs are pretty stiff, and I've got quite a bit of speed. We'll back this up, and let's go. That just cracks me up every time I look at it. Upwards. Hit backflip. Anyway, there we go. That's actually how you use the wheel joint 2D. Now, to be honest, I always end up writing the code for this myself. I've never actually used the wheel joint 2D, but for some reason I get the feeling that this week I'm going to be playing a lot with it. Anyway, that's it for this video. Can't wait to see what you guys make with it. And as always, I'll see you in the next video. Bye-bye. So if you like the video, go ahead and hit that subscribe button down below. It really does help me out here on YouTube. And go ahead and follow me on Twitter. I can be a pretty chatty guy over there when I'm not walking through a forest or being stalked by eagles and falcons, lions, tigers, and bears.